Hello, everyone. Today we're continuing with the 2023 November paper for physical science, paper two, so chemistry. We're moving on to question two, which is the long form answers. In the previous video, we had covered the multiple choice questions, so that's in a different video. In this video, we're going to be looking at question two, which we have here. We can see question two has quite a couple questions coming up to 16 marks. So let's dive straight into that. So the first part of the question, they give us a table with some organic compounds. Some are just the names. Some is a detailed formula, structural formula, um, and some is just the chemical formula without the bonds. Um, so moving on to the first question, uh, define the term organic compound. So this is a really easy question at this level. Uh, an organic compound is basically anything with carbon bonds. So you can phrase the answer however you like, as long as somewhere in your answer you mention carbon bonds. uh, you'll get full marks. You'll get the full mark as long as you have carbon bonds in your answer. Um, moving on to question two, write down the IUPAC name of the compound E. Okay, so this is our compound E over here. Now we must remember IUPAC names is just like the scientific conventional way of naming compounds. So in this question paper, I think they made a mistake on these two these two carbon hydrogen groups over here. There's some hydrogens missing, but just ignoring that. The way you do this is you try to find the longest straight carbon chain, which in our case is this chain here, and that'll be the foundation of naming our compound. So what we do is we definitely know that, well, actually, there's four carbons. The longest carbon, straight carbon chain, no matter which way you do it, is four carbons. So we want to include the functional group in our main chain, like the main functional group. So maybe it's better to do our straight carbon chain this way with our four carbons. So that we know that we have four carbons and there's a double bond, so that's butene. And then these two methyl groups here, and just pretend this is CH3, are then off branches. They're not part of the main chain. So with that in mind, we can easily name this. So following IUPAC conventions, we have first we have to give the number of where those off branch methyl groups are. So we always start counting from the main functional group. So in this case, the double bond. So if this is carbon 1, and this is carbon 2. So the first methyl group is on carbon 2. This is carbon 3. So the second methyl group is on carbon 3. So we know we have 2, 3. And then because there's two of them, we say dimethyl. And of course, we know this is butene. So, and the double bond is on the first carbon. We say but, and then we have to say which carbon the double bond is on, which is the first one, butene. So this is how you would name that compound: 2,3-dimethyl but 1-ene. And that's our 2 marks. Uh, moving on to the second one, compound H. So compound H is a lot more straightforward. we can see that our main carbon chain consists of four carbons once again. Um, but of course, in this case, we have just a double bond oxygen, and we know if this is in the middle of a group, this makes a ketone. So this compound is a ketone, and we know the convention of naming a ketone. You just say ONE at the end of the name, so it's butanon. So you both are acceptable. You can say, well, the functional group is on the second carbon. You always give it the lowest number, so you wouldn't say the third. You'd say the second. So you could say it's buta dash 2 on to say that the ketone group is on the second carbon in our chain, or you could just call it butanon. Um, Both are acceptable in this case. Um, or if you don't enjoy putting the number in in the middle of the word, you can also put it in the beginning. This is also acceptable. Butanone. So all three answers are acceptable. You'll get full marks for whichever way you prefer. So going on to question number 2, 3. So write down the structural formula of compound B. Okay, so we have compound B here. So they basically want us to draw the structure showing all the bonds. Now for this one, um, what we have to do is first unpack what's in the brackets. So let's start with the methyl group here. So CH3. So CH3. I won't put the hydrogens in for right now. I'll just draw the carbon backbone. And then we have these CH2 groups, and we have three of them. So there's another three carbons. So 1, 2, 3. And then this is bonded to a carbon, and then bonded to um, double bond oxygen, single bond to a methoxy group. So we know that when we see this sort of thing here, this is an ester. Okay. So what we have another carbon, double bond oxygen, single bond oxygen, and then the last CH3 group. And then you can populate the hydrogens. I won't draw it in, so it does take some time. But that's basically how you would break this down. So just to recap here, what you need to know is how to unpack the brackets. And when you see this COOCH3, you need to recognize that's an ester, and then realize that it has to be represented this way. But yes, that is the structural formula for compound B. Next, they want the structural formula for compound C. So compound C, okay, compound C has a bit more to unpack. So let's see. 4-ethyl, 3, 3-difluorohexane. So we know we have hexane, so maybe it's a good idea to first start by drawing in our carbon backbone. So hexane is 6 carbons. So let's just draw in our 6 carbons. 1, 2, 3, 4, 5, 6. And then it's 3,3-difluorohexane. So we know that um, we have two fluorine atoms, and they're on the same carbon. They're on the third carbon. So uh, yeah, what you can just, it doesn't really matter in this case. You can count from either side because the molecule is pretty symmetrical, whichever way you decide to count. So I'll just count from left to right because it's easier. So 1, 2, 3. So we're going to put both our fluorine atoms on this carbon. This is our carbon number 3. So this is the difluoropart 3,3. And then 4 ethyl. So an ethyl group is just two carbons like this with their hydrogens. I'm not drawing in the hydrogens because it gets a bit messy. But of course, when you do this in the exam, you should definitely draw in your hydrogens. Yeah. So this satisfies the question. So we have our carbon backbone, hexane. We have our two fluorine atoms, difluoro, 3,3. And we have our ethyl group, 4 ethyl, the two extra carbons. And that is the structural formula for compound C. Okay, on to question 233. General formula of the homologous series to which compound E belongs to. So compound E is it's an alkene. So unfortunately for this one, you just gotta know this formula. I'll give it to you. It's basically CnH2n. This is the formula for alkenes. And you can even check that compound E does satisfy this formula. But yeah, this is one of those things you just gotta know it. Um, Moving on to question 234. Structural formula for the functional group of compound F. So let's have a look at compound F. So structural formula is basically something unique, something different in the molecule. And obviously, we can see that what's different in this molecule is definitely this carbon oxygen bond, but specifically how it's positioned in the molecule. So, to represent this fully, we can't just say carbon oxygen because we can get carbon oxygen bonds um, in alcohols, in aldehydes, in ketones, in esters. Um, so we need to specifically define how that carbon oxygen bond is positioned in the molecule. So in this case, we have a carbon, carbon, double bond oxygen, and then another carbon. So this defines a ketone. So this is the functional group of a ketone. That's what compound F is, and that's how we write the structural formula of the compound. If you want to be more specific, you have to denote that the carbons attached to this are saturated and like not a double bond or anything like that. And this will get you full marks. All right. So moving on to question 235. So the IUPAC name for the alcohol needed to produce compound B. So esters come from reactions involving alcohols. The alcohol provides the methoxy group. So if you have um, something like ethanoic acid or butanoic acid, these organic acids, and you react it with an alcohol, you get an ester. So that's the reaction. And the organic acid, like the carboxylic acid rather, contributes to the longer, well, not the longer, but to the first part of the molecule, this part. And then the alcohol will always contribute to this part. So if we redraw that molecule, or I'll draw it in shorthand though. So CH3, CH2, 3, and then carbon, double bond oxygen, single bond oxygen, CH3. So this part of the molecule comes from the carboxylic acid. So here in the question, they're asking us which alcohol is needed. So the alcohol part is this part. So if we're to reconstruct our our alcohol, we can write it as CH3 oxygen, and then just add a H. So this we can see is methanol. So we know that the answer is methanol. All right. So we're making good progress. Moving on to question 2.4. Write down the letters of the compound that is a functional isomer of G. So functional isomer just means they have uh, the same functional group, um, basically. So same functional group. So let's have a look at G. What is G? So again, G, we can see here, this group down here, this is the functional group. This is a carboxylic acid. And then we know hexanoic acid is also a carboxylic acid. So I think this acid is one, two, three. This one should be uh, propanoic acid, if I'm not mistaken. So we know these are both carboxylic acids. Um, so you just from that, we know that the functional isomer of G is definitely D. All right. So definitely D. Okay. Are chain isomers of each other. So chain isomers just basically mean they have the same number of carbons. Um, sorry, did I say D? Uh, yeah, yeah, hexanoic acid. So chain isomers basically mean that they have the same number of carbons. So you just have to count one, two, three, four, five, six. Um, G has six, and if we go through any of the other molecules, which ones have six with the same number of oxygen atoms as well? And whilst E does have six, it doesn't have any oxygens, so it can't be a chain isomer. Going through the others, heptanoic acid has seven carbons, not six. Uh, Hexane has six, but there's no oxygens available. H has five, F has five as well. Oh, it does have six, but only one oxygen. This one has two. So again, the only answer is D. D fits. D fits the the requirements. Um, Going back to 2.4.1, I just realized that the answer is not D because a functional isomer, it doesn't mean it has the exact same functional group. It just means that the functional groups have the same atoms, just arranged differently. The answer should be B because if we break it down, so is the functional group of B is a carbon double bonded to oxygen, single bonded to oxygen, and then CH3. Okay. And the functional group of this is carbon, double bonded oxygen, single bonded OH. Um, these are functional groups of each other. The only difference is the CH3. So in G, the CH3 group is part of the main chain, so it's on the other side of the functional group. That's why they're functional group isomers. So if you took all the atoms in the molecules and rearranged them, you could get either molecule. They have the same number of atoms. So that's what an isomer is. An isomer is not just having the same functional group. So the answer for 2.4.1 should actually be B, compound B. All right, and that concludes question 2.